Hello, class. It's Mr. Kablan here, and we're now going to begin a new chapter here. And it's going to be dealing with algebra, and it's only going to cover two lessons here. And today's lesson will be focusing on one and two-step linear equations. So, like I said, this is basically the bread and butter of any type of mathematics course because what we're doing in each case here is solving for the variable or the letter in each question that we're going to see here. And the way we do that is performing opposite operations. And what that means is that when you take a look at an equation, what you want to do there is to take a look at the variable or the letter, whatever the letter it may be, and figure out what operations you need to do to leave it alone alone when you have an equation here. So that's what we're going to focus on in this particular lesson. And we're just going to specifically look at one and two step linear equations and see what order we do things when we have an equation. So the first thing we're going to do here, we're going to start off by looking at the various one-step equations when we're solving them. So that means each case here, we're going to perform only one step here, and that will be that will be the only thing we need to do in order to solve these problems. Now, if you take a look at the three problems you have on the screen, you notice that they have a couple things in common. Okay, you notice that each equation here has a letter x, but notice that each equation in this particular screen here has something in common when it comes to having one letter and a number, and that number and letter is separated by either a plus or a minus. So what we want to do in each case here is to take a look at the letter and leave it alone. So we need to figure out what we need to do in order for us to leave that alone. So if you take a look at part A here, what we want to do here is to leave the x. And anytime you see a letter and a number separated by either a plus or a minus, you just need to take a look at the number and then move it to the other side of the equal sign. So in this case here, all we need to do here is to take the plus 3 and then move it to the other side. Okay, now when that positive 3, okay, which is again just an operator too as well, it's going to be also addition. When it goes the other side, it changes itself to a negative and then becomes subtraction. So what we wind up doing here in the next step here is that 3 is going to subtract itself from the 5 that's already there. Now, when a number goes to the other side of the equal sign, okay, always write it after the number that's already there, okay, and then just change the sign. So what we have here is 5 minus 3, which gives me 2, okay? So what we want to do here is I'm just going to introduce you in terms of how to perform a check. Now, you do not need to do this all the time, okay? You only do it when you're asked to do it. And basically, we just want to make sure that our answer is indeed correct. And the way we break this apart is breaking apart the equation into left side and right side. So what that means here's the left side is whatever's to the left of the equal sign. So that's going to be the x plus 3. And the right side here is going to be whatever's on the right side of the equal sign, which in this case here is the 5. So all we're going to do here is replace the 2 there for the x, okay? And that'll give me 2 plus 3, which gives me 5. Now you notice the left side and the right side are exactly the same, so that tells us that our answer is indeed correct. Okay, so for the next thing that we're going to do here, if you take a look at part B, okay, notice in this case we have x minus 7 is equal to negative 2. So just like the previous example here, we're going to leave the x alone simply by taking this negative 7 in this case. Okay, you always include the sign, and we're going to move it to the other side. Now, when this negative 7 goes to the other side, it then becomes a positive, and then what you're really doing on the other side is adding it to the negative 2 that's already there. And the negative 2 plus 7, that's going to give me 5. All right, and last but not least here, notice the only difference with this question is that I just rearranged this, where the letter and the number are, but the technique is actually exactly the same as example A. So we're going to leave the x where it is. So all we're going to do here is take the 8, okay, and then move the other side there. Now, before we do that, I forgot to do the check for the previous one. So we're going to just check our solution for the previous example by taking a look at breaking it down to left side and right side. So the left side here is x minus 7, and the right side here is negative 2. So you notice that when we put in the x here for the 5 here, 5 minus 7, well, gives me negative 2. So that's going to give me the right side there, okay? So for part C, now that we've done that, okay, all we're going to do here is take the 8, and since it's positive, when it goes to the other side, it becomes a negative and subtracts itself from the 9. And then 9 minus 8, that's going to give me 1, okay? So again, keep in mind that anytime you see a letter and a number that is separated with a plus or a minus, you just need to move the number, okay? Now, that's going to be different from what we're going to see in this next one here, because if you take a look at the next set of examples, notice what we have here is a number and a letter. However, the number and the letter are grouped together. Now, what we want to do here is you can see in the top part, it says leave the variable alone by performing opposite operations. So each of these questions here, D, E, and F, okay, the number and the variable are both grouped together by multiplication. Okay, so what we have to do here is the opposite of that, which is division. Now, for each case here, what we want to do is to divide both sides by the coefficient, which is just the number that's attached to the variable. And the way we do that is we're going to divide both sides by the number that's attached to the x. So for part D here, we're going to divide both sides here by 5. And the reason why it does that is because the 2 5s on the left side there cancel out, and then 40 divided by 5, that's going to give me 8. Now we're just going to do another check again so you can use to see how to do it. So in this case here, remember the left side is whatever's to the left of the equal sign, which is 5x. Okay, and the right side here is 40. And what we want to do here is to replace the x there with the 8 in this case, because that was our answer. So when the x is then replaced with the 8, okay, 5 times 8, that will give me 40. So as you can see, the left side and right side are exactly the same there. Okay, so we're done to check there. Let's take a look at part E. Now you notice what we have here is negative 7x is equal to 28. Again, the negative 7 and x are grouped together by multiplication. So in this case here, what we're going to divide here is we're going to divide both sides here by negative 7. Okay, and then negative 7s on the left side cancel out, and then 28 divided by negative 7, that's going to give us negative 4. All right, and let's do a check for this one by substituting x equals negative 4 into the left side and the right side. Well, specifically this one's just going to be the left side. So left side here is negative 7x, and the right side here is a 28. So when we substitute the negative 4 in for the x here, that will give us negative 7 times negative 4, which gives us positive 28, okay, which is the right side. All right, and last but not least here, for part F, notice that the number that's attached to the x, the coefficient, that's going to be negative 9. So we're going to divide both sides here by negative 9. Okay, and then negative 27 divided by negative 9. Okay, remember two negatives, when they divide into each other, that'll give us a positive. So that'll be x is equal to 3. All right. So we've seen what happens when we have a letter and a number separated by a plus or minus. In this case here, you notice that the number is attached to the letter here. So the last set of one-step solutions we're going to look at is what happens when we have fractions. Now, anytime you see a fraction, okay, remember that the operation between the top and the bottom number is always division. So the opposite of that is multiplication. Now, the reason why this is important because multiplication is the step that we need to perform for this in order to isolate the x. And the way we do that is we're going to multiply both sides of the equation by the denominator, which is the bottom number, okay? So pay very close attention to why we do that. So notice that for the equation x over 6 is equal to 3, the bottom number of the denominator here is 6. So we're going to multiply both sides here by 6, okay? Now when we do that, the 2 6s on the left side cancel out, and then 6 times 3, that's going to give me 18. Okay, so you can see here is that when you multiply both sides by the denominator, all it does, it cancels it out. Okay, and then you multiply the right side there as well. Okay, now we're just going to check our answer here just to make sure it's indeed correct. So we're going to substitute the x equals 18 into the left side in this case here. So remember the left side is x over 6 in this example, and the right side here is 3. So when we substitute the 18 here for the x, 18 divided by 6 will give us 3 here, which is the same thing as the right side. Now, notice that, again, anytime you see a fraction, in order to get rid of it, you just need to multiply both sides by the bottom number. So if you take a look at the next example, we're going to do the exact same thing. The only difference in this case is that our number happens to be negative. So even if the number is negative, you still need to multiply both sides by whatever that number is, including the sign that's attached to it. So in this case here, we're going to multiply both sides by negative 5. Okay, and again, the reason for that's the two negative 5s on the left side cancel out, and the negative 5 times 9 gives me negative 45. Okay, so just to do a check for that one, Okay, our left side in this case here is x over -5, and our right side here is 9. So when we substitute the -45 in for x, -45 divided by -5 gives us a positive number, which is +9, which is the same thing as the right side. Okay, so again, I want you just to see here is that again, anytime you have a fraction, always just remember to multiply both sides by the bottom number. Okay, so for this next example here, okay, same thing. I just threw this one just to show you an example of what happens when we multiply two negative numbers here. So again, you're going to multiply both sides by the bottom number here. So we're going to multiply both sides by -2. That cancels out the two negative 2's on the left side here. And then -2 times -11 will give me +22. Okay, because when you multiply two negatives, it will give you a positive. Okay. Okay, so now that we've seen every single example of one-step solutions, we're now going to combine two of them to, well, to create two-step solutions. Now, what you have to do for this one is understand that we are going to require two steps in order to isolate the letter here. Now, keep in mind what you want to do is to leave the letter alone, okay, until you get to the point where you have the number that's in front of it, and we're going to figure out what to do from there. So, anytime you see a letter and a number separated by a plus or a minus, the very first thing you need to do here is to take care of the number. So just remember, we need to leave this alone first, and we'll take care of it when we need to get when we get there. So the first step here, in order to isolate the x here, you're going to take the number, which in this case here is -5, and it's going to go to the other side and add itself to the 7 that's already there. Okay, so remember that any number that goes the other side always changes to the opposite sign. So since we had a negative number, when it goes the other side, it becomes positive and it adds itself to the 7. And then 7 plus 5, that will give me 12. Now, that step there where you move the number and then you add it to the number that's already there, that's step number 1. So for the final step here, you notice the 3 and the x are grouped together. So in our final step, we now need to divide both sides by the number, which in this case here is 3. And then x is equal to 12 divided by 3, which gives me 4. Okay, now just to do a check for this one, okay, we're going to substitute the x equals 4 into the left side, which is in this case here is just 3x minus 5. Okay, and the right side here is 7. So when we substitute the x equals 4 in for the x, so if you go 3 brackets 4 minus 5, so 3 times 4 gives me 12, and then 12 minus 5, that's going to give us 7. Okay, and you notice the left side and the right side here are indeed the same. Now, when you do the check, when the right side and left side are the same, that tells you that your answer is correct. All right, for part B, again, you just have to, again, remember that you're going to leave the letter alone first. So the first thing we're going to do here is we're going to take the +3. It's going to go to the other side and become a negative and subtract itself from the -1 that's already there. Okay, so when we have -1 minus 3, that becomes -4. Okay, and then last but not least, we're now going to divide both sides here by 2, and this will give me x is equal to -2. All right, so again, anytime you see a letter and a number separated by a plus or a minus, always move the number first. Okay, the final step in these cases here, notice that involves the division of the number attached to the x. All right, now this question over here, put a star beside this one because this one's a little bit special. We're going to approach this the exact same way. Keep in mind there is a fraction. Okay, now you notice that in this case here, we have a letter, which happens to be a fraction as well. We have a letter and number attached by a plus in this case. So what we need to do first, believe it or not, isn't to get rid of the fraction, not for this example anyway. Okay, what we want to do first is to take care of the numbers. We're going to move the number first. So step number 1, we're going to take this 5. Okay, and we're going to move it to the other side, and it's going to subtract itself from the 10 that's already there. So that's going to give us 10 minus 5, which gives me 5. Now, you notice that from this step, okay, this is now the step where we get rid of the fraction by multiplying both sides by the bottom number, which in this case here is 4. So in this case here, we're going to multiply both sides here by 4. That cancels out the 2 4s on the left side, And then 4 times 5, that's going to give us x is equal to 20. Okay, so again, this if you compare this example to the last two that we looked at, okay, the steps are exactly the same. The only difference in this case here, when you have a fraction, okay, you multiply both sides by the bottom number in the final step. Now, just to double check that we have the correct answer here, we're going to do a check here by putting x equals 20 where the x is. So the left side in this case here is 5 plus x over 4, and the right side here is 10. So what we're going to do the next step here is we're going to replace the x here with the 20. Now we're going to do this one step by step here. So 20 divided by 4, that's going to give us 5. So what we have here is 5 plus 5, which gives us 10, which is the same thing as the right side. All right. So again, these are all the different examples that you can see here using two different steps that we saw from the previous example. All right. So next thing over here, notice that what we have here again is a fraction, okay, and a letter, and we have a number. Now, I'm just going to go back to the previous question for a moment. Okay, notice that this question here and this question here are very, very different. You notice that for this one, we had to move the number first, okay, because the term with the letter and the number are separated by a plus sign in this case. If you take a look at this one, notice what we have here is that the term with a letter, okay, and the fraction are grouped together. So in this case here, what we want to do here is to get rid of the fraction in our first step, okay? So this is different from the previous one. Now, the reason why we're going to get rid of the fraction in the first step here is because the fraction is part of the term that involves the letter. So we're going to multiply both sides here by 5. Okay, and the reason for that is it cancels out the 2 5s on the left side. Now, it's very important that you see why we cancel the numbers out, and that's why I always put 2 red slashes when that happens, because you can now see what's remaining. So for the next line here, 5 times 12, that's going to give us 60, and you notice that 3x is left alone, so I'm just going to rewrite it like this. 3x is equal to 60. So we got rid of the fraction first for this one, as I said before, because it's grouped together with the variable or letter term here. And for the final step, now you divide both sides here by 3. Okay, that cancels out 2 3s on the left side, and we're given x equals 60 divided by 3, which gives me 20. Okay. That's pretty much it. All right, so last example we're going to look at, we're actually just going to look at a word problem and then just do the same steps that we did in the previous example. And there's Justin Timberlake there. And what we have here is that the recording studio charges, according to the equation, C is equal to 35H plus 275. C represents the total cost, and H represents the number of hours. So what we want to do here is we're just going to use the equation in order for us to solve this particular problem. So for part A here, it says calculate the total cost if a singer uses the studio for 9 hours. Now, first things first, always start off by writing down the formula of the equation that's given in the problem. And before we actually figure out what we need to do for this one, okay, we just have to remind ourselves what the letters represent. So in this case here, the C represents the total cost and H represents the number of hours. Now, it's important for us to remind us that because when you take a look at what the question is asking you, we need to figure out where that number is going to go. So in this case here, it says we want to calculate the total cost, okay, if a singer uses the studio for 9 hours. So 9 hours, okay, so that's going to be the number. So 9, again, is the number of hours. So that's going to replace the letter H in this case. Now remember that anytime you replace a letter for a number and there happens to be a number attached to it, okay, don't forget to put brackets around it like this. Okay, and then 35, and in brackets 9, okay, plus 275. That's the same thing as 35 times 9 plus 275. That's going to give us a total there of $590. And again, since this is a word problem, okay, please make sure you put down a sentence there. All right. So last but not least here, what we want to see here is we want to take a now take a look at this question. Okay, and now take a look at it. Okay, using the same equation, but this time one slight twist to it. So it says here, if the total cost to use a studio is $800, how many hours would the singer be using? So in this case here, we're given the total cost. Now we need to figure out how many hours this person will be using the studio for. Okay, so for this case here, instead of replacing H, we're now going to replace C with the 800 because that is now the total cost. So the C here is going to be replaced with the 800. Now, this is where it gets a little bit tricky because up until now, we're used to seeing the letter being on the left side. In math, okay, it's one of those languages where you can actually read things from left to right and right to left. The reason why I'm pointing that out here is because what we want to do here is we're actually going to leave the 35H exactly where it is. So I'm just going to put a box around that just as a reminder that we're not going to touch that until we have to actually deal with it. So if the 35H isn't going to move, you're probably asking, well, what is going to move here? So in this case here, what is going to move is the 275, okay, or the positive 275. And then when it goes to the other side, it's going to subtract itself from the 800. It's already there. So anytime, again, as a reminder, anytime a number goes to the other side of the equal sign, it always changes to the opposite sign. So this is, again, our first step where we take the 800, okay, and we're going to subtract the 275 from it. And that's going to give me 525. Now we need to take a look at the H here. Okay, so for our final step, okay, we now need to isolate the H by now dividing both sides by the number that's attached to it. Okay, so in this step here, we're going to divide both sides by the 35 because 35 is the number that's attached to the H. Okay, and when we do that, 525 divided by 35, that's going to give us 15 hours. Okay. All right. And that wraps up this particular lesson. So you can now work on the workbook or the textbook if you have it. And I will see you in the next lesson.